this is Ms. DB, and in this video we're going to go over how to do some of the problems on the 6.1 worksheet, which is on properties and attributes of polygons. So there's a lot of new definition. You should take some notes so that you have this information handy. So first of all, we can name a polygon by the number of sides, and this table here tells you what the name would be depending on how many sides. If it has more than 10 sides, there are some special names after that, but we're just going to call it an n-gon for after 10 sides. And so if it had 15 sides, we'd call it a 15-gon. If it had 100 sides, we'd call it a 100-gon. Some more words that you have to know is convex and concave. A convex polygon is when all the points are in all of the diagonals would lie in the interior of the polygon. If you can make any diagonal that lies outside of the polygon, then you would say that it is concave. So in that example that has the concave, let me just draw the diagonal here. You could connect these 2 points here. Whoops, that's not a very straight line. But that diagonal there would be outside of the polygon, so that's the definition of concave. You might have learned concave in elementary school, that it caved in somewhere. It looks like maybe somebody pushed this side in. Also, a regular polygon, all sides are congruent, and all the angles are congruent too. So it's not enough to have all sides congruent. The angles also have to be congruent to be a regular polygon. So that's a very special case. So in the first ones, you have to answer 2 questions. You have to say whether yes or no it's a polygon. And if it is a polygon, then you have to name it by how many sides it has from that table up above. I should have said too that the definition of polygon is in your textbook. It's not on this page. So the definition of polygon is that it is, I'm going to read it quick, a figure that is made up of only straight segments. So it can only have straight segments, and the polygon also cannot have any segments that go outside of, let's go down a little bit, like number 4 is not a polygon because those segments here do not connect at a vertex. So each segment that forms a polygon is a side of the polygon. The common endpoint of 2 sides is the vertex of the polygon. And you actually learned the definition of polygon way back in chapter 2, section 4. And the definition, we learned it when we did biconditional statements. So in there it said a polygon is defined as a closed plane figure formed by 3 or more line segments. Each segment intersects exactly 2 other segments only at their endpoints, and no 2 segments with the common endpoints are collinear. So on page 98 you will see the definition of a polygon. At the top of the page. All right, so if it has any curved sides, then you're going to say not a polygon. And then you name it by a number of sides. And then in number 5, 6, and 7, you have to answer 2 questions again. You have to say whether it's regular or irregular, and concave or convex. So you'll get 2 answers for each of those. All right, now we're going to do the polygon angle sum theorem. There's actually a journal, the first thing in the week folder, where you will do an exploration of this to help develop this formula. And the formula is that if you have these are your number of sides. Let's just do the first one. If you have 4 sides on your polygon, subtract 2 from that number, multiply by 180. That tells you the sum of all the interior angles. So however many sides you have, you subtract 2, multiply that answer by 180, and that will tell you the sum of the interior angles in your polygon. Now, if you have a regular polygon, you do that, and then you can divide by how many sides you have to know how much each angle is. That only works for regular only, because otherwise the angles are different measurements. And then the polygon external angle sum theorem says that in any polygon, no matter how many sides it has, if you add all of these external angles up, it'll always equal 360. So you can use that to find specific measures as well. Okay, so in 8, 9, and 10, you're going to find the sum of the interior angle measures. So you take how many sides it has. You might have to look up in the chart a nonagon. So a nonagon at the table at the top says that's 9 sides. Okay, so we have 9 sides, and you're going to use this formula here. The number of sides minus 2 times 180 gives us the sum of the interior angles. So you would take 9 minus 2, and you'll take that answer times 180, and that will be your answer for each of these. So each time you'll change the n, or the 9 in this one, to whatever, how many ever sides you have. Now in 11, 12, and 13, you have to find the measure of each interior angle of a regular polygon. So we can't answer this until we first figure out the sum. So let's do number 11. So to find the sum of the interior angles, we use the formula where you take the number of sides minus 2 and multiply by 180. So 5 minus 2 is 3. 3 times 180 is 540. Okay, so we took 3 times 180 and got 540 for the sum of all the angles. But a pentagon, here's a pentagon, 1, 2, 3, 4, 5. It's supposed to be a regular pentagon, mine is not. A regular pentagon is that all sides and all angles are congruent. Which means that if the sum of all of these 5 angles is 540, I can find the measure of one of those angles by dividing by 5. So 540 divided by 5 is 108. So I divided this by 5, and I got 108 degrees for each angle. So that's how you'll do those problems. Find the sum first, then divide by how many angles it has, which is equal to how many sides it has, in order to find the measure of one angle. And remember, this only works for a regular. Okay, then 14 and 15 is for an exterior. All of the exterior angles, no matter how many sides it has, is equal to 360. So the number of exterior angles that they will have will be equal to how many sides it has, or how many angles it has. So an octagon has 8 sides, and if every one of those, so there's 8 exterior angles, and the sum of those would be equal to 360. So you can just divide by 8 in order to find one of those exterior angles. Okay, and then in number 16, it says find the value of each interior angle of this quadrilateral. Well, I know that the sum of these angles would be what? Let's figure that out. So the rule is to take n minus 2 times 180. That gives you the sum of the interior angles. So this has 1, 2, 3, 4 sides. So 4 minus 2 times 180. Well, that's the same as 2 times 180 is 360. So the sum of all of these angles is 360. Well, let's write that as an equation. Let's start up here. So that means that 2n plus 6n plus 2n plus 5n, I just added up all of these expressions, will be equal to 360. So we can combine our like terms on the left side. We have 2 plus 6 is 8, plus 2 more is 10, plus that's 15n's. 15n is equal to 360. So now we can solve for n by taking 360 divided by 15. And we get the n is 24. Now we know what n is, so we just go back and solve for each of these angle measures. We would put the 24 in for n. So for angle r, measure of angle r, we'd go 2 times 24. And for measure of angle s, we'd go 6 times 24. And so on, and you will answer what the measure of each angle is based on that. And number 17 will be done the same way, except we're starting with a hexagon. So the first step again is to find what is the sum of all the angle measures. So you have to go and you have to use this formula. And this time n is equal to 1, 2, 3, 4, 5, 6 because it's a hexagon. So you'll start by finding the sum of the angle measures, and then you'll write an equation, 2a plus 5a plus 4a, and so on, will be equal to what you get for this answer. 18 is a little different because these are exterior angles. So this plus this plus this plus this plus this is all going to be equal to 360 because the exterior angles theorem says that the sum of these exterior angles will always be equal to 360. And you'll be able to solve for n using that. All right, if you have any questions on this worksheet, please let me know. Have a wonderful day.